Hey guys, this is Rishandra. So today we'll continue with LangChain. The first topic for today is memory. So LLMs are normally stateless and each request is independent. So for example, for conversation one, the user says that my favorite language is Python. So when a second conversation starts, and the user asks, what is my favorite language? So when the AI has no memory of what your favorite language is, so it says I don't know. But when you already say to the AI that your favorite language is Python, so it has a memory of what your favorite language is. So when you ask the question about what my favorite language is, the AI will give the answer as your favorite language is Python. And next is the types of memory. And the first one is conversation buffer memory. So conversation buffer memory like stores the complete conversation. So for example, uh, if the user says that my name is John, then the AI replies, nice to meet you, John. So it like stores the and whatever conversation you have after that. So it stores the conversation buffer memory. It stores all the conversation. Next is conversation summary memory. So instead of storing everything, it sto it stores a summary of the conversation. So for example, instead of just storing like 20, 50 messages, it just stores the summary of all those 50 messages. And the last one is conversation buffer window memory. So conversation buffer window memory, it stores only recent messages. So like instead of just uh, storing all the messages from like 2 days ago or 3 days ago or maybe like yesterday, it stores the recent ones like the last 5 messages or maybe the last 10 messages. Like it's the recent whatever recent conversation you had. Next topic is document loaders. So document loaders allow LangChain to read external files. So for document loaders, the supported sources are PDF, CSV, TXT, websites, and Word documents. So, for example, you upload a PDF file, and the PDF file is sent to the document loader, and the document loader reads the text, and then it sends it to the line chain, and then to the large language models. So that is about document loaders. And next is text splitters. So LLMs have a limited context window. So a large document cannot always fit into one prompt. So text splitters divide documents into smaller pieces. So for example, you have a large PDF that has like 50 or maybe like 100 pages. So that what the text splitter does, it splits those 100 pages into maybe like three chunks or four chunks. The for easy for so that the AI can easily understand the whole PDF. So the important parameters to check during the text splitters are chunk size, and chunk overlapping. So chunk size, it's like the number of characters or tokens per section. So for example, the chunk size is like 500 words or maybe like 50 words, 20 words. It could be anything. And chunk overlap means the repeated text between the chunks. So this mean so the chunk one has like letters A, B, C, D, E, and chunk two has D, E, F, G, H. So this maintains context between two words. Next is embeddings. So embeddings convert text into numerical vectors. So example, if you write a text, I love Python. So and Python. So it is converted into like numerical vectors like 0.21 or 0.45, 0.68, 0.89. So the computer understands numbers better than the text that you wrote. So embeddings, they also capture meanings. So for example, if you write like two sentences like I like AI and I love artificial intelligence. So these sentences have similar meanings. So their numerical vectors will be close. Next is vector databases. So vector databases store embeddings and allow similarity searches. So for example, you have Chroma, Pinecone, FAIS, FAISS, and VV8. So the process is first you upload a document and then it goes into like the embedding model and then it goes to numerical vector and then to the vector database. So when the user asks like explain employee benefits, so the system searches like which stored document is the closest and then it retrieves the information. Next is retrieval augmented generation. And yes, it is it is the third time I'm repeating it, but retrieval augmented generation is common for like large language models prompt. It's common in large language models, prompt engineering, and even in language chain. So, uh, retrieval augmented generation combines retrieving the documents or text and generating the answers. So it allows an LLM to use external knowledge. Next, next is output parsers. So output parsers convert LLM responses into structured formats. So, for example, if you have the LLM output like name John, age 25. So the parser converts it into like a structured kind of format, like using like JSON format. So output parsers are normally useful for like APIs, applications, or maybe databases. Next is LangChain Expression Language. So we in short known as LCEL. So LCEL is a modern way to create chains using a simple syntax. For example, it's like mod prompt model and then parser, meaning you send the prompt output into the model and then parse response. So the benefits of LCEL is like simple syntax, streaming support, async uh, execution, and better debugging. Next is callbacks. So callbacks allow us to monitor the what happens during execution. So for example, like when model starts, or maybe like when respond completes, or when an error occurs. So it's used for like logging, debugging, and monitoring. Next topic is LangChain applications. And the first one is AI chatbots used for AI chatbots, example, customer support assistant, and it's used for memory, RAG, and agents. Next is document answering questions. So, for example, like asking questions about PDFs. It uses document loaders, embeddings, and vector databases. And the third application is AI search engines. So, for example, like search company knowledge. And AI search engines uses retrieval and agents. And the last one is personal AI assistants. Example, AI that manages emails, calendars, and tasks. So, and it uses tools, agents, and memory. Next is uh, Lang chain. Ne- Next, there are like some additional topics in LangChain, and they are not necessarily used anywhere, but I will still tell you about it. The first one is LangGraph. So LangGraph is an extension of LangChain used for building complex AI workflows. So it represents applications as graphs, and it's useful for multi-agent systems, long-running tasks, or maybe complex workflows. Next is LangServe. So LangServe helps deploy LangChain applications as APIs. So it can convert LangChain applications into like REST APIs and others. And the last one is Langsmith. So Langsmith is used for monitoring and debugging LangChain applications. So it helps with tracking prompts, evaluating responses, and finding errors. So in summary, LangChain is a framework that helps us build real-world AI applications by connecting LLMs with external systems. So this is about LangChain, and um, that's the end of LangChain, and that's it for today. And I'll see you again tomorrow. So yeah, take care. Bye.